This lesson, I'm going to explain how to reduce a radical when we have a variable underneath, and then you should be able to explain by the end of this video how we do that. So just a brief overview of what we'll do is we'll split our variable into two parts. We'll split it into one part that has an even exponent and one part that has an odd exponent. And the odd exponent that we're going to use here is the power of 1, and you'll see why in a minute. So what we'll do is after we've split our exponent into two parts, we'll cut the even exponent in half and put it outside the radical, and then the odd exponent will stay inside the radical. So if we have an even exponent, we can pull it out of the radical. So even exponents are perfect squares. You can think of it that way. So example 1. So simplify, assume that all expressions underneath the radicals are non-negative. In other words, we're just making sure that we don't have a negative underneath the square root, because remember, you can't take the square root of a negative number. So we're just assuming that all these numbers, all these variables represent positive numbers. So the square root of x to the 17. So 17 is an odd number. So what we'll do is we want to make 17 even. So the way that we'll do it is we're going to reduce the power by 1. So we're going to say this is x to the 16. But we can't just reduce the power by 1 and call it a day. We have to account for that one exponent that we're lowering by. So the way we do that is we multiply by x to the first. So we've lowered this by 1, so x to the 16th, but we have to account for that 1 that we lowered it by. So this is why we're introducing the x to the first. So just remember your properties of exponents, x to the a times x to the b. As long as your bases are the same, so our base here is x, we're going to add exponents, x to the a plus b. So this is the property that's allowing me to split up 17 into 16, x to the 16 times x to the first. So now what we'll do is now 16 is an even number. We can divide 16 by 2, and we'll move it outside the radical. So 16 divided by 2 is 8. So this will be x to the 8. And then now notice the 1 is an odd number. You can't reduce 1 any further. So this will just be square root of x to the first. Or if you like, you could just write it like this. X to the 8 times the square root of x. So both of those are acceptable. So your goal is to get to an even exponent, and then you divide the even exponent by 2. So example 2, we have h to the 16th times k to the 7. Well, h to the 6th, sorry, that's h to the 6th. H to the 6th is even, and then the 7 is odd. So we're going to do like we did in the first example. Since 6 is already even, we're going to leave it. So it's going to say h to the 6th. K to the 7, we're going to reduce that by 1. So it's going to be k to the 6. That makes it even. But we got to account for that 1 that we reduced it by. So we're going to have to put k to the first. And this is all multiplication. So now my even exponents get divided by 2, and it goes outside the radical. So this 6 divided by 2 is 3. So this is h cubed. K to the 6 divided by 3 is, sorry, 6 divided by 2 is 3, so it's k cubed. And we have what's left is k to the first inside the radical. Now, they didn't tell you to assume that these were positive, but we are going to assume the variables are bigger than or equal to 0. Just to make sure that we're only getting positive numbers. So really, for all the examples that we see today, we're going to assume that the variables are positive, that are positive or bigger than or equal to 0, just to make sure that everything is defined. Example 3, square root of 25y to the 21st. So now we have a number and a letter, and this is fine. We can handle this. So 25, you think of your perfect squares, 25 is one of your perfect squares. So you do want that list out. If you don't have it, there's a link in Google Classroom for it. So the square root of 25 is a perfect square. The 21st, well, that's odd, so I'm going to reduce it by 1. So it's going to say y to the 20 times y to the first. just accounting for that one that I reduced 21 by. And now we can simplify this. So square root of 25, we know the square root of 25 is 5. Y to the 20, 20 is even, so we're just going to divide that by 2. So that's y to the 10. So those are now gone, and all we are left with is y to the first. So this will be square root of y. So 5y to the 10th times the square root of y. Example 4, the square root of 90m. So again, you're going to have a letter and a number here. So we're going to have to reduce 90 because 90 is not one of our perfect squares. But it is divisible by one of our perfect squares. It's divisible by 9. So this will be 9 times 10. And then m has the first power. We can't reduce anything to the first power when it's underneath the square root. So we're just going to leave that alone. So this will be square root of 9 times 10 times m. So we can do the square root of 9 is 3. Can't do the square root of 10. And we can't do the square root of m. So we'll just leave those both underneath the radical. So we can't reduce those any further. So this will be 3 times the square root of 10m. Simplify again, we're assuming that all the variables are positive numbers. So here we have a number and a whole bunch of variables. So let's start with the number. So 24, that's divisible by 4. So this will be 4 times 6. And then I'm going to rewrite this as a square root of 4 times 6. 10 is even, so we can say a to the 10. 12 is even, so this will be b to the 12th. C to the 5, 5 is odd. So since it's odd, I'm going to reduce the power by 1. And then I'm going to show where that other one is going. So there's my c to the first. And then here is the game just simplifying. So find your perfect squares. So 4 is a perfect square, so that's going to come outside the radical. Square root of 4 is 2. 6 is not a perfect square, so I'm going to leave 6 alone. A to the 10, 10 is even, so I'm going to divide that by 2. So that's going to be 5, and that takes care of that. B to the 12, 12 is even. 12 divided by 2 is 6, so it's b to the 6. C to the 4, 4 is even. 4 divided by 2 is 2, so this is c squared. And then what am I left with in my radical? What haven't I crossed off yet? So I have the 6, and I have the c to the first. Again, you could show the first power there if you wanted to. So this will be 2a to the 5th, b to the 6th, c to the squared, and then the square root of 6c. That would be my answer for this one. So here's that if you need it. Another example, so simplify again, we're assuming that all the variables are bigger than or equal to 0. So square root of 64 divided by y squared. So in this one, notice we have division. When we have division, what we can do is we can take care of the numerator and the denominator separately. In other words, we could first do the square root of 64, and then we could do the square root of y squared. So we could just rewrite it. We could just split it up. This is a quotient property that allows us to do this. We'll just take care of the top, and then we'll take care of the bottom. So the square root of 64, well, this one's nice because the square root of 64 is a perfect square. So the square root of 64, that's 8. So my top is 8. And the y squared, this is what we're just looking at, is y squared. The 2 is even. So we can take that out of the radical. We're just going to divide it by 2. 2 divided by 2 is 1. So this will be y to the first. Or if you like, you could write it as 8 divided by y. But we should note y cannot equal 0, because if y is 0, then we're dividing by 0. And remember, if you divide by 0, if you put that in a calculator, it will give you an error. And I have one more example. So example 7. So x to the 6th divided by y to the 4th. Again, we're assuming y is not 0, because otherwise we're dividing by 0, and we are not allowed to divide by 0. So just like in that last problem, we're just going to handle the top, the numerator on its own, and we'll handle the denominator, and we'll see what we get. So we'll handle the top. So square root of x to the 6. So 6 is even, so we're just going to divide that by 2. So this will be x cubed divided by the square root of y to the 4. We'll handle that on its own. Again, this is the quotient property that's allowing me to do this. So 4, so y to the 4, we're just going to divide 4 by 2 since 4 is even. So this will get you y squared. So this is my answer. So x cubed divided by y squared. So you should be able to do the reducing radicals with variables, which is in MathXL. If you have questions, please let me know.